the Hungarian Export Promotion Agency office in Greece, would like to thank you and to welcome you to this special webinar that we have organized under the auspices of the Embassy of Hungary in Athens. This webinar aims to give to the Greek participants the opportunity to meet ZalaZONE Mobility Hub and additionally to reveal cooperation opportunities that are related to mobility and smart city applications. Our aim is to set a communication and a cooperation bridge between the ZalaZONE and the Greek ecosystem. We would also like to express our special thanks to the Greek Ministry of Environment and Energy and the Greek Ministry of Infrastructure, Transport and Networks, the Greek municipalities of Athens, of Thessaloniki, Trikala and Iraklion, as well as to all the Greek institutions, universities and organizations that have expressed a genuine interest for the Hungarian hub and are willing to explore all potential synergies. During this webinar, we will attend and discuss 3 individual presentations from ZalaZONE. First, Mr. Robert Siddi, the sales manager of AVL-ZalaZONE Proving Ground, will present the Automotive Proving Ground in more detail. Secondly, we will listen to Dr. Viktor Tihanyi, the leader of research and innovation team of the ZalaZONE Automotive Proving Ground, explaining the scientific work and the research development activities. Finally, Dr. András Háry, the CEO of ZalaZONE Industrial Park, will present the ZalaZONE Science Park concept. At the end of each presentation, there will be time for questions and discussion. We expect that the total duration will not exceed 90 minutes, 1.5 hours maximum. For the webinar's optimum operation flow, all participants are kindly requested to mute their microphones. During the webinar, if you want to speak and add a question, you must press the raise hand symbol and then to wait for the host to give you permission to speak. Throughout the webinar, you will be able to type, as you have already, any question or anything you want to say through the chat function. And now at this point, it is my pleasure to give the floor to Mr. Siddi. Welcome, Mr. Siddi, the sales manager of AVL-ZalaZONE Proving Ground.
Okay, good morning. Hello to everybody. My name is Robert Siddi. I'm the head of sales of AVL Proving Ground in Hungary. Normally I have 1.5 hours for myself to present the ZalaZONE Proving Ground itself, so I will try to put the 260 hectares of proving ground into 15-20 minutes. We will see how it will fit. Okay, I give my best. You can believe me. Okay, so I will share this one. Okay. Okay. Hopefully you enjoyed this very small video, and to be also honest, you are the first in the world who saw this video because it's not published yet. A little bit about ZalaZONE and AVL-ZalaZONE. The proving ground started in 2017 with the construction site, and we are still under construction. Also, some modules are already ready for testing and available. The global idea was pumped on in 2008, and yeah, then 2 to 6 years to the thinking phase. What would be the need of an proving ground in Hungary and for Europe? Put then the phase on it, and in 2014 they started already the planning, and in 2017 the construction started. The proving ground is built fully by the Hungarian government, so it's financed by the Hungarian government. However, the commercial operation is done by AVL-ZalaZONE. AVL-ZalaZONE is a joint venture between AVL in Hungary and the Automotive proving ground ZalaZONE, with a share of 74% for AVL Hungary and 26% for Automotive proving ground ZalaZONE. This is our service portfolio. You can see from the bottom right to the upper left. This is our flow. First steps, we give out our modules for the customers so they can make their tests as they want. To make it more stupid than in the first step, we don't care really in the beginning what they are doing. They are coming, they are testing, they are going, but we already thinking more and wanted to provide also services packages to the customers, which mean in the halftime, like here in the service line, infrastructure, technical service, we want to provide total engineering package to the customers, which mean we are bringing their car from the customer to the proving ground, making the tests they wanted to have on their test list, and shipping back with the test results the car back to the customers. Also, the testing on the proving ground is one thing. We have also the possibility, and I will come later to that one, to make public road testing on normal public roads, and also we have a trilateral cooperation with Austria, Slovenia, and Hungary, which allows cross-border testing as well. As I mentioned, we have some extra service near to the modules only. So we have a logistics service handling the customer vehicle transports and their equipment, arranging hotels. We have of the already available and current modules, we have an HD mapping which we can provide to our customers. We have some drivers. If there is necessary to have drivers on the proving ground, they cannot bring their own. We can also provide them. As I mentioned, we have engineering service as we are part of AVL List GmbH in Austria, which is an independent company of a private held person, which are providing engineering services to automotive customers. We have also here in Salek a department who is handling special others purposes, and due to our building here in the main building where I'm sitting, we can have conferences up to 300 persons. This is the layout of the proving ground. It's already, you have to also admit, it's an older picture. It's done 2 months ago. Therefore, it says older because we are still under construction. You see a lot of empty places, which are already, we do some construction as well. I will come later to that one. What is already finished is it's the A module. It's a dynamic platform with a diameter of 300 meters, an acceleration rate of lane of 760 meters, and a separate return lane of probably 1 kilometer. This is a place where you can probably do all the let me say critical maneuvers without any penalties. It means if you go in the dynamic platform with a high speed of maybe 160 to 170 kilometers per hour, make your maneuver, and you still have some problems with the car, cannot stop it in time, you have still enough space to have a safety stop at the end. Even if the 300 meters aren't enough, with another 20 meter of a deep 60-70 centimeter gravel, which gives you also a kind of safety zone there. Then we have our B module. It's a high-speed handling course. It's 2 kilometers long, have a width of 12 meter, and have also on both sides a 20 meter gravel security space. Also on the high-speed handling course, we have a multi-lane section. It's a 3-lane section of 450 meters length, which gives you possibilities for platooning, lane changing, and lane keeping assistant tests. Then we have our C, the braking platform. You also saw that one in the short film, with 8 different surfaces. I will come later to the different surfaces, what they mean. Each surface have a length of 200 meters, an acceleration lane of 750 meters, and also a separate return lane. Then we have D, what is an USP in Europe. It's our smart city. Have a space of 15 hectares, which is 150,000 square meters, with 5 different areas. I will come also later on that, which are the different areas. Then we have E, this is the technical building where we have our workshops. You saw that in the film as well. And we have F, which you not saw in the film, only in the beginning. This is our main building where we can have conferences up to 300 persons. Then we have some modules which are still under construction, but will be ready end of this year. It's, for example, G. It's a railroad system, which means it's a highway a system of 2.5 kilometer length, also with a multi-lane of 2 times 2 lanes with a length of 500 meters. Then we have H. This is our highway section, 1.5 kilometer long, 2.2 lanes with 1 security lane for high-speed maneuvers, for high-speed lane changing, lane keeping, and some other scenarios as well. Then we will have in 2021, within the high-speed handling course, a low-speed handling course with 1 kilometer length, 6 meter width, fully watered. Then we have here a separate ADAS surface with an acceleration lane of 500 meters, total length of the surface 250 meters times 65 meters. We'll have here our slopes with increasing of 5, 12, 18, 25, and 30%. And at the end, all around in 2022, at the end, we'll have here around high-speed oval. It's a 3-lane high-speed oval, which gives you a possibility to drive with a neutral speed of 200 kilometers per hour. This is also, I have to say, an older picture, is newer than the other one. You can already see here in the field here the other surface. You can see more here the slopes. You can see more here within the high-speed handling is already the wet handling course, and also the bridge for the crossing of the highways also ready. Some more in details, as I mentioned, the dynamic platform with 300 meter diameters, acceleration 760 meters. What is interesting on that platform is that on the return lane, we have put on some special markings. It means that you can make your real testing on the dynamic platform. You have to still some testing doing, some other testing, some lane keeping testing. You can do that on the normal return way. So you have not to use another module, a different section. You can do it within your test on the dynamic platform, going on the return lane, make still some lane keeping or lane changing others testing as well. This is the high-speed handling course, and you can see in the picture on the right side already the contours of the low-speed handling course as well. As I mentioned, 2 kilometers long, 2 kilometers and 40 meters to be in the right one. A width of 12 meters, and on the left, on the right side, and 20 meters of gravel as a safety zone. And here you can also see the multi-lane section of 3-lane, 450 meters long, also divided and marked with special marking. Here's a marking of a motorway. On the left side is a marking of a highway. then it gives you a possibility to make platooning and others testing as well here on that module. This is the brake measurement track. As I mentioned already, and you saw in the film, there are some different surfaces, beginning with the chest surface, a normal asphalt with a mu of 1. Then we have the specialty of the low mu section of built out of tiles, Japanese tiles, 10 by 10 centimeters, handmade, which gives a mu of 0.1, which is ice. Then we have next by the blue basalt, which gives you a mu of 0.3, which is also very close to ice. Then we have an asphalt mu 0.8 as a mu split if you want to make some braking tests with a normal surface and the ice surface on different tires. Then we have a treated concrete of 0.6. We have another reserve surface still for mu split of 0.8, and on the right side we have our aquabathing basin, which we can fill up to 5 centimeters with water. All of the surfaces have a length of 200 meters. As I mentioned, 750 meters is the acceleration lane, and still at the end, if you cannot bring your car to stop, which is in case of the low mu very difficult, maybe for passenger car they may stop the car. For commercial vehicle, for buses and for trucks, it's quite impossible if you have a speed up to 80 kilometers to stop on the 200 meters of the low mu surface. Therefore, we have at the end another 150 meter as a security zone. And also on the way back on the return lane, there is still roughly 1 kilometer long with different markings as well on the line, that you can also make on that surface, on that module, also some lane keeping tests as well. This is, as I mentioned, our rule road system. They have two functions. One is to combine the modules. It means that if you come here from the technical building on the left side, crossing the motorway, then you can decide you go on the motorway directly, or passing only the motorway and going to the modules like the high-speed handling course, or the braking platform, or the dynamic platform, or use the rule road as a cycle course. So you can start here, go to the highway, go to the round corner, and get down back on the rule road and have a circle of different scenarios. This is our smart city, and as I mentioned, this is the biggest smart city in Europe. There is no other proving ground, no other smart city in that size in Europe. The next one is in Asia and in America. It's divided in 5 different sections. The first section is the low speed parking area, where we really have some low speed tests with a parking area, with a logistic yard. Then we have a multi-lane high-speed area. It's the second area. It's a 2 times 2 lanes section, where you can have within the city the high-speed test, which means up to 70 kilometers per hour. Then we have our downtown area. It's the section 3, where we will build mid of next year also some building facades out of glass, stone, and iron, 10 meters high, as I mentioned. And then we have a suburban area with different road sections, with also a small hill inside. And then we have the T-junction area. It's a normal outside city area with very straight roads, with several function also on the road itself, some parking areas, some bus stops direct or next by to the road, to simulate all the kind of scenarios you may have in the city and outer city. That was the vision in 2014, and right now we are here. So if once the buildings will stand here in the downtown area, I think we will quite have the perfect copy of the vision. These are the modules which are coming then in the next year. As I mentioned, the other surface, the slopes. We'll also have a bed road section. There's also 8 different surfaces on it. And as you can here see on the right side, this is the high-speed oval. It's a new dual speed of 200 kilometers per hour. This is our blind communication network to assure the data exchange and the communication vehicle to vehicle, vehicle to X. Therefore, we have here on the proving ground a 5G network, which is right now, it's a public network operated by Telecom System and by Vodafone. The plan is to have next year an old campus network, which cannot access from outside. As you also can see here, we have some special data collection points for our customers then next year. And as you may recognize, the most will be in the smart city, because that will be the most data collection function there. This is a kind how we can execute complex test scenarios, and for sure Viktor will come late more in detail to that one. I mean, it's combining of real scenarios out what you have in the city. I mean, your roads and so on. You have some special inputs you can give from outside. The software is combining these tools, and then you can simulate several things out in the smart city, like that one, that you can move your real car in the smart city, and then giving into the software there may be bicycle is crossing the street, and the car will stop automatically. In real life, you will only see there is a car, there is no other target, and the car stops, because the software is simulating there may be a bicycle crossing the street, but you will not see it, but the car will recognize that, and you can simulate that one. These are the software we are using right now to handle all these scenarios and the cases. These are our active safety equipment we have here already on the proving ground, which means some targets, some pedestrians, an adult and child, cyclist, motorcyclist, and also some animal dummies. We have also dummy cars. We will have till end of this year real target vehicles of different types. We have, of course, all the carriers that we need for these pedestrians, like a small platform, the large platform as well for the cars that we have to move within the city. We have some driving robots, and we have a car which we can control by wireless. Also for the communication, we have the necessary DGPS base station here. As I mentioned, testing outside the proving ground is also possible. We have here a trilateral cooperation with Austria, Slovenia, and Hungary for autonomous driving, crossing the border, what will happen within the car with the time crossing the border, in which time he will recognize the new systems, the new telecommunication, how will react the car, and is he able to react in time, and how will go. It's also a topic maybe of Viktor, who can explain it in more detail for sure. What I also said, we have the possibility in Hungary since April 2017 to make some testing in our road network in Hungary, which means you can test your prototype cars and the autonomous cars up to level 4 on the complete road network in Hungary without any time restriction, any territorial restriction. This means you can go within any city and on any street and make your level 4 testing. For sure, there were some requirements you have to fulfill. Once they are fulfilled, you can have this permission and can go and can testing on the total road network. These are our workshops. Also, already saw in the film, we have 8 workshops for passenger cars. One workshop can fit up to 2 passenger cars with a separate office next by with 6 to 8 people space. We have the big garage workshop for our trucks and buses, and we have some offices which we can also provide to our customers. As we are not only a proving ground for passenger cars, we have also the possibilities to let in here commercial vehicles, which mean trucks, buses, and that kind of categories. This is an example what can be tested on the high-speed handling, because even it's a high-speed, also fits to commercial vehicles for platooning, for lane changing scenarios. And also dynamic platforms is very specialized for commercial vehicle to make also some platooning, some dynamic testing, and you can see here, and also some others testing as well. Also in the smart city, as we have a logistic yard, we have the possibility for autonomous driving commercial vehicles to give them the possibility to test. As you saw also in the vehicle for some ADAS testing, it means crossing pedestrians, the streets, and then the system have to react on that one, or normal parking situations for autonomous commercial vehicle as well. Then we have the possibility, and this is the part I only wanted to mention in one slide of Dr. Háry András. It's our science technology park, which means gives a very good possibility for our customers, new customers, which can have their own small office workshop directly in connection to the proving ground, which means they can have here a kind of research and development center, a small one, a workshop one, which gives them the possibility they can develop their car, make some modification, and within 20 meters, they're already in the proving ground going out for testing anytime they want. This is a very good possibility, which right now I cannot remember any other proving ground providing that in that closeness to the proving ground itself. That was very, very fast. I hope I was a little compressed, but I think it was the time I have, and hope a lot of questions will arise, and hopefully I can answer them as well.
Thank you very much, Mr. Siddi. Now, if anyone would like to speak, to ask a question, let me check. I don't see that anyone have a question.
They're still impressed for sure. They're still impressed.
Yes.
They work all the information on here.
That's for sure. That was very interesting. Thank you very much. Also, anyone who would like to have a question to Mr. Siddi, of course, afterwards, after the webinar, can communicate with HEPA. You all have our number, our email, and we can go directly to Mr. Siddi through HEPA. So, thank you very much. And we can move on with Mr. Tihanyi. Mr. Tihanyi.
Hello, good morning.
Hello.
Everyone. I would like to introduce myself. So I'm Viktor Tihanyi from ZalaZONE Proving Ground Research and Innovation. I'm a team leader there, and at the same time, I'm also an assistant professor at the Technical University of Budapest. So I will present you the research and innovation activities inside ZalaZONE. Can you see my screen? That's perfect. So let's start with the topics. I would like to provide you a small overview about what are our major points that we are focusing on. So first of all, cutting edge research is the most important from our side, of course. Then we are focusing also on the education, I would say future proof. I will talk a little about later on. Dissemination of results is also very important part, and finally the knowledge transfer. Let's check inside ZalaZONE where we are located currently. So as you can see on the bottom left side of the overall proving ground, we have now currently a built-up research and technology center, which is continuously improving. So we will have new buildings, but Dr. Háry will speak about this, I'm absolutely sure. Therefore, I skip this topic now, but we have currently 3 universities who are hiring offices and workshops nearby ZalaZONE, and 1 research institute. And I'm really proud that I can tell you that we, from the research and universities part, we have a small proving ground at the area. If you see my pointer, then it is here located at the bottom side of the big proving ground, which can be used for dedicated research activities. We have also dual education programs with the universities where they can send their students to spend time at ZalaZONE research. We have also at this place currently also industrial laboratories and the capability for startup incubation. Regarding the education that is dedicated to the ZalaZONE activities, 2 years ago, we have initiated a new master program at the Technical University of Budapest called Autonomous Vehicle Control Engineer, that is in English language, and we are expecting students from worldwide here. And this is a very special master program because it focuses really on the automated vehicle related topics, and we cover practically all those topics that are relevant here for CCAM related science. We have also another one that is computer science for autonomous systems. It's in another university in Budapest, and we have started as well a new program. It's a so-called B-Prof program, which is a little bit less than a bachelor that is focusing on vehicle testing. So those students who choose this education form will be able to support the testing of vehicles on a proving ground, for example. A little overview about our current partners whom we are collaborating with. You can see here that we have a lot of partners, also academic partners worldwide, as well as automotive suppliers and commercial companies. Just to mention someone here, we are collaborating with Bosch, Knorr-Bremse, AVL, of course. From the perspective of the academic partners, we have a very strong collaboration with TU Graz Virtual Vehicle. We are also collaborating with not only automotive commercial partners, but as well as from the mobile suppliers like Hungarian Telecom, and also from the perspective of the 5G device suppliers like Ericsson. We have also very strong relation with Hungarian public roads and also Budapest public roads. As Robert mentioned formerly, we are also planning to extend the activities not only on the proving ground, but to support testing and later on automated vehicle operation from the public road perspective also. About the dissemination activities, we are typically hosting 3 international conferences annually that are dedicated conferences. There, last year we had 24 Hungarian conference and workshop attendants. We were participating more than 30 international events like fairs and other kind of not scientific conferences, and we have a lot of scientific publications annually, where the number is continuously increasing. Of course, due to the coronavirus situation, this year is a breakdown in this, but we expect significant increase in the near future inside these activities as well. As a next topic, I would like to talk you about our current research projects and the exact topics what we are focusing on. We have multiple ongoing projects. Currently, the list you can see here is not complete because we have also new ones in the list as well, but just to mention, you can see that we have a significant amount of budget for research related activities. For example, we have dedicated research project for the automated vehicle systems research dedicated to the autonomous proving ground at Zalaegerszeg, involving 3 universities from Hungary. We have a higher education excellence program where we are focusing on AI-related research. We have also initiated collaborative research programs with Austria first, where we would like to extend to other countries as well. We are currently in discussion with German partners as well as with the Slovenian partners to initiate similar bilateral research projects. And we have also commercial partners whom we have collaborative research project, like for example Bosch, what you can see here. Some words about our fundamental research activities in the connected and automated mobility topic, what we are focusing on. So we are practically covering all areas on the fundamental research side. First, I can say environment perception is a really strong activity at our side, where we are focusing on from the raw sensor signal processing up to the AI-based fusion or AI-based perception methodologies. We are also very active in the testing methodologies of perception systems, and I also include here into the perception part the HD mapping related topics. For example, as Robert mentioned last time, we were also generated the HD map vectorized and point cloud data of the ZalaZONE, which will be available soon for all our partners who are coming for testing. This is a centimeter accurate level HD map of the areas. On the next part, we are dealing with decision and control part of the automated vehicle related topics. We have AI-based decision methodologies in research, static dynamic trajectory planning and following, and we have control on the execution level as well as the research topic. And we have also a special part, which is a new part, I would say. This is vehicle in control in case of instability. I will talk a little bit more later on this field also. Communication technology is also a very important part for us. As you may know, there are 2 evolving technologies currently available. One of them is DSRC, the other one is 5G. Actually, we don't know which one will be the winner. Therefore, we are focusing on both, also on the lower layers of the communication as well as on the application layer. And of course, on cybersecurity, which is currently very important topic due to the impact on the future automated mobility. This is not only in the research activities currently. If you take a look in the world, for some years, most of the big automotive companies are started to deal with cybersecurity related topics. Many of them are acquiring existing cybersecurity companies, for example. And last but not least, in the fundamental research part, simulation technology, where we have currently our own tools developed, as well as we are using most of the available commercial softwares in our research team, where we can do standard software-based simulations, as well as we are able to customize the softwares. And for example, we are making a lot of kind of co-simulation where we combine the different software tools advantages as well as with our own tools in order to have a tool set that is capable for the highest level of abilities, state of the art and beyond. Regarding our applied research activities, at the moment we have two automated vehicles that are available at ZalaZONE. We had developed a Smart for 2 vehicle that is completely by-wire vehicle that can be controlled from any kind of software or CAN interface or Ethernet interface, whatever. We have also developed existing functionalities in it in order to demonstrate. So we have bullet parking ability fully autonomously for this vehicle. We have also a traffic jam pilot where we can realize camera and radar and LiDAR based lane keeping vehicle, so low speed ACC control, as well as fully automated lane change with this vehicle. And we have also implemented a special platooning function on a DSRC communication basis. This vehicle we can offer also for our research partners, and we can do collaborative testing or research activities where they have the ability to get a completely automated vehicle to do the research if someone does not have the opportunity for that. The other vehicle for research purposes, that is a by-wire vehicle on the steering and the throttle level, currently is a BMW M2, where we are using a steering robot and some manipulation with the throttle control. And with this vehicle, now we are realizing automated drifting. I will show you also a small video around. This is a very interesting research activity because in the future we think that for safety we will step into a next phase where the automated vehicles will be not only able to control the vehicle in the stability situation, but it will be able to control as well the vehicle beyond stability in edge cases. From the environment perception point of view, we have also a fully equipped Honda vehicle that you can see on the right side that is equipped with all of the state-of-the-art sensors you can see. So cameras, we have 7 cameras on the vehicle, 3 LiDARs, multiple radars, differential GNSS, and also thermal and night vision cameras, where we are able to collect data in a synchronized way, and also we are able to do real-time operation of the perception system during the vehicle operation. We are not only focusing from the perception point of view, the vehicle side, but we are focusing currently as well on the infrastructure side. I will talk a little bit later on. Another very important thing is that from the research point of view, we are doing special testing methodology researches. One of them is the so-called vehicle-in-the-loop methodology, where we can combine our simulation technologies with our real vehicle testing, where we practically bypass the perception system by a virtual world during the vehicle testing, and from the virtual world that is running in real time in parallel, we are able to inject back to the vehicle object level, or currently even raw sensor data level information into the automated vehicle system. We have an even more complex testing methodology that we are calling scenario in the loop methodology, where we are doing the same. So with the real vehicle testing in parallel, we are running a simulation in real time, where we are capable also for the vehicle in the loop object level or sensor level information injection back to the vehicle. But from the simulation server, we are also able to control real proving ground elements. For example, dummies, pedestrian dummies, or even moving platforms or target vehicles. The current status that we have done a POC and we have ongoing application with Bosch on this system currently. And last but not least, a new topic what we are focusing on is that we are doing a research on complex cloud-based central system, where our target is to build up a real copy, so-called dynamic map of the environment in real time of the road users, where we will have the real-time object information in the cloud that can be used for providing information back to the vehicle, can be used for automated vehicle testing, and also, for example, the data for accident reconstruction and the support of the previously mentioned scenario in the loop system. In this project, our partners are Knorr-Bremse, Hungarian Public Roads, Ericsson Telecom, and some Austrian partners as well. Okay, and finally, just some highlights that out of the theory, what I mentioned, you can see some videos, what we are doing. So on that one, you can see our automated vehicle that is doing a wallet parking application here. And we are doing a parallel real-time simulation at the same time. You will see the simulated environment soon. And you can see that the vehicle in the simulation is acting in the same way as in the real world. And now a pedestrian, a virtual pedestrian comes in and the vehicle started to brake. In the next scenario, you can see that from the simulation server, we will control our real test dummy in the proving ground with a time to collision calculation to come in front of the real vehicle. This was our next scenario. Here, my colleague will drive the vehicle to the next scenario. But I can also tell you that in this video where we recorded, this was done not with an internal computer inside the vehicle, but the computer was an external server that ran the simulation, and the communication was a real-time 5G communication that was implemented in the ZalaZONE proving ground last year. So it was done in 2019, May, where the proving ground opening scenario take place. So here you can see the next scenario is a traffic jam pilot, where our vehicle reacts on the simulated front vehicle in the same way as it would have been existing there. And then the final scenario is coming, and my colleague will change the direction, and we will do the same with the real vehicle. So you can see that the Skoda vehicle will come in front of our smart, and it will do the same traffic jam pilot with an automated lane change at the end of the scenario. During the event, we were applying a very huge LED wall, you can see on the right side, and the audience was able to see the parallelly running simulation in real time from the demo location. Okay, so then the final scenario is starting. You can see that the vehicle will do the same traffic jam pilot functionality, and my colleague will push the turning indicator, and it will react with a complete automated lane change operation finally. So actually, this was the final scenario here, and then practically this demo ended. And just a very short final video to you. So this is a recording of our BMW M2 vehicle that with it we are doing a so-called automated drifting. You can see that the controller of the vehicle is continuously keep the BMW in a stable drift state. Our next target is to realize not only the stable drifting, but as well as to implement a predefined trajectory with the vehicle. So thank you very much for your kind attention. And if you have any questions, then please ask.
Thank you very much, Mr. Tihanyi. I think we have some questions, and because many people have asked questions in the chat area. I'm sorry, just a moment. Come on, Siddi. Mr. Tihanyi, please stop sharing because we see your presentation. Thank you. Thank you very much. Now, we have some questions. And I would like to ask all attendees that they have questions, please, to push the raise your hand button now, because they are writing at the chat and we cannot share it orally. Okay, so Ms. Sadipa, I will make you now, I will allow you to talk and promote you to panelists to see you. Just a moment, please. If you want to see you, Mrs. Adipa, you can, we can share your video if you want to.
Hello.
Hello.
Can you listen to me?
We can listen to you. If you want to share your video, you can. But if you don't want
no,
to,
I'm fine. Thank you very much. Thank you very much for your presentation of ZalaZONE. Yes, my question is, first of all, I participate in this webinar from CRES, the Center for Renewable Energy Sources and Saving, Athens, Greece. And my question is if ZalaZONE was a result of a project of yours. Maybe you mentioned some bilateral cooperations with Austria or Germany, or if it was a private investment or a public investment.
The investment is from the Hungarian government.
I see. And what is ZalaZONE's legal form? Is it a research institute?
No, actually, maybe Robert can answer better for this question.
We have to divide, because ZalaZONE is a product. ZalaZONE are not only the proving ground. We have the ZalaZONE proving ground, which is a public investment.
Yes.
And itself, the operating, it's a normal LTD, which is operating that proving ground. So it's a public investment, the total proving ground.
Okay, Mrs. Adip, are you fine with the answer?
So the proving ground is a public investment, but it also has parts of a smart city and hotels and a lot of research like a university. So in total, does it have a specific legal form?
No, because we have some more legal forms. There is no.
Okay, I see.
So the investment is done by the Hungarian government. And then we are divided.
So it's divided.
We have some commercial operation. We have some research and development, which is mainly operated by the universities.
Okay, I see. Thank you very much.
You're welcome.
Thank you. Just a minute. Now, we have. I would like to give the the word. I'm sorry. Excuse me, just 1 minute. Just a moment, please. Just a moment. I have also another question from Mrs. Maria Zarkalvoula, also from CREST. Just a moment, please, to give the word. Hi, Mrs. Zarkalvoula, we can hear you. Please.
Do you hear me?
Yes, yes, we can hear you.
Good
Hello.
morning.
Good morning.
Good morning. I'm Maria Zarkalvoula from CRES, the Greek state consultant. The logical question after.
I'm sorry, I just.
In which way the running cost of ZalaZONE project covered?
Can you please repeat the question, because we didn't hear you? I made a technical change, so we didn't hear you well. So can you please repeat? I'm really sorry, Ms. Zarkalvoula. Please repeat your question.
Yes, I would like to ask in which way the running cost of ZalaZONE project covered. I understand that there is some expenses every year, every day. So in which way these costs covered?
They are covered by our customers. We have also customers coming here for testing. Probably 4 or 5 customers per week are here, always on the modules and testing. So these are fully covered by our customers.
So you cover the costs from private sector, you mean, from private customers?
Yes. It's a normal commercial business model. So we have something which of course costs, we have to cover by somebody. The somebody is our customers who are coming. It's like OEMs, it's like Audi, Volkswagen, it's like tier 1 supplier like Bosch, Knorr-Bremse, Continental, which are using our testing facilities. And for sure they have to pay because it's a business model.
So you operate like a private company, you mean?
Yes. Yes.
Okay.
Okay, actually, so it depends on which part we are talking. So if we are talking on the business side, then Robert is right. If we are talking about on the research side, the research activities are covered by different kind of projects funded by EU or funded by Hungarian government. This depends on.
Do you hear me now?
Yes.
So I can say that ZalaZONE project is a profitable company, let's say, or non-profitable.
At the end, they have to be a profitable company, but there is no business model. Yes.
Okay.
Because if you're a starting company, in the starting phase, you are not profitable because you have to search for customers, you have to acquire customers, you have to provide services, but it's normal startup company behavior. But at the end, have to be profitable. Otherwise, it's no business model. Yes.
Yeah. Okay. Thank you.
Okay, thank you very much. If there is anybody else that would like to make a question, can now press the raise your hand button in order to see. Otherwise, I can see that there are no questions. We can proceed to the final presentation, and we can see Mr. Dr. Háry András, the CEO of the AVL-ZalaZONE. Now, you can see on your left that it's Robert Siddi, the name, but they have the same function. This is Dr. Háry András. Welcome, Mr. András. Just a moment to. I think you can start, Mr. Háry. Okay. We can now. Please check again your voice.
Can you hear me?
Yes, we can hear you now. Okay, thank you.
I use the name of Robert because I also had the opportunity to present from his machine, so his laptop. So we are at the same place at ZalaZONE main building. So I would like to give you a short overview on the ZalaZONE Science Park program, which is the surrounding of the proving ground. Okay. This slide shows the general layout of the proving ground. As Robert also mentioned, the ZalaZONE proving ground is a special combination of classic vehicle dynamical testing modules and functionality of autonomous and automated testing. As autonomous testing is a key strategic direction of ZalaZONE proving ground, we considered, and it was also part of a governmental decision, that we have to build up the related know-how, research and development activity next to the proving ground. That was the reason why the layout also a kind of integrated model, showing that, as you can see, the red circle in the R&D campus, we also try to attract universities to bring vehicle-related and autonomous vehicle-related researches to the site. That's also a place for the customers. So those customers who are permanent users of the proving ground, they have the opportunity. It's more economical for them to establish a local development center. There's also a dedicated zone for this. So this is the question, but we heard just recently that the customers and the companies are the key users of the proving ground, and also R&D institutions, of course. So that's also the reason why this kind of integrated layout includes zones for both companies. This slide shows the basic elements of the ZalaZONE Science Park concept. So first of all, the Industrial Development Centers is the pillar which is intended to establish as a service and serving the industrial companies, and the ZalaZONE Science Park and Industrial Park is a place where we would like to see those companies who are constant users of the proving ground. The proving ground is operated in a kind of rental model, so companies can come here, they rent a module for an hour, for a day, for a week, they can go home. But some companies are the constant users, and if they use the modules for a lot of time during the year, then it's better for them to establish a local site. So this is one pillar. The other pillar, what was the explanation and the presentation of Dr. Viktor Tihanyi, it's the university R&D labs. So this is the pillar through which we would like to localize the background know-how and research units. And the zone, what I have shown in the slide before, gives the place also for these organizations. The human knowledge and background means that we also have a special training program. So researches and also serving industrial companies, for example, through engineering services, require the necessary engineering and researcher background. So that's why it is an integrated part of the Science Park concept that we put special efforts and activities for this pillar. Incubation and startup is about promoting new ideas, and through that promoting new startup companies. The whole environment what we built here at ZalaZONE is very strongly connected to international partners, both through industrial partners and also through university partners. So there are around 50 university partners all around the world. And so the international connections and integration to the international flow of knowledge is also a key part. And as a whole, world of ZalaZONE is also a part of the local economy. There are also projects with local companies. So this is the high-level concept of the pillars of the ZalaZONE Science Park program. And you can see that the professional areas are, first of all, vehicle industry, but also related industrial technologies and ICT technologies are the part of this this concept. Currently, we have AVL as the first client decided to establish their local development center next to the proving ground. The construction will start soon, employing around 100 people. And a research and technology center was also built that was handed over last year, September. This is the place for the universities and some smaller service providers. So this is the logic of the combination of customer zone and R&D zone next to the proving ground. We also have an extension area. So this is a complete industrial park concept what we are working on. And as that, you can see in the slide that in Hungary there are 9 key science park programs. The ZalaZONE one is a bit special because this is a science park in the meaning of it's a more industry-oriented activity and industry-oriented services, and also researches here are very firmly experimental based. We can also call this environment as a kind of business and R&D ecosystem. Here in this slide, there are some keywords. What is about ZalaZONE Science and Industrial Park as an ecosystem. The basic concept is that this is a combination of business, R&D, and education. And there are also classic engineering fields like design, materials, and technologies. But also there are also vehicle-related and digitized technologies like mechatronics, vehicle development, simulation, and ICT. So these are the 6 competence areas we are building in ZalaZONE Science Park. The current status you can see here in the picture. It's a pyramid-shaped building. Is includes offices, some laboratories, and next to that there's also a workshop run by the Budapest University of Technology, and also some workshops are run by the István Széchenyi University. And these university groups, local groups, and also some other small and micro size companies started to operate this center from last year September. And as it's also very important that you can see through the technology partners the whole cooperation and the R&D projects are connected to global leaders, technology and know-how leaders. So it's also an important aspect here that we should be able to connect and cooperate with leading technology partners. This pyramid shape building and the workshop next to that are already full. So that's why we have launched the development of the next buildings of the science park. So this is a vision. And the groundbreaking of this next stage was in October this year. So by early 22, these buildings, what you can see here, will be built, and also further laboratories will be created. What is the professional service line of the science park and this industrial park? This slide shows the basic areas of the Budapest University and István Széchenyi University and the Zoltán Baj Institute. So first of all, from the classic simulation through so-called driver loop simulation and the powertrain testbed, and finally the proving ground. That's a special chain of services, and this chain also is usable, and the people and the companies and the university groups here at ZalaZONE can also make R&D projects, and they can also offer services for the industrial partners, or those industrial partners who are the clients of the proving ground, but not exclusively. So also it's a key point that the R&D partners here and the technology service providers can work anywhere in the world and also cooperate even with the Greek companies. Sensor, radar, it's also a key line, data, and of course autonomous mobility testing, and there are also the classic fields. The service available now, it was mentioned by Viktor that the local team has knowledge on the most frequently used traffic simulation softwares, and then in cooperation with the proving ground, this group can offer simulation services. The background scientific knowledge is given to this team by the Budapest University team. So this is a cooperation of the Budapest team, the local R&D team, and the proving ground. And these services are already available. In the next stage, the István Széchenyi University will establish 3 laboratories, a powertrain testbed, dyno to examine and analyze the powertrain features, and there will be also sensor, camera, radar calibration laboratory. These equipment is under purchasing, and the buildings what I have shown before is also under construction. So by the end of next year, this laboratory will be available, and by early 22 there will be a special so-called driver in the loop simulator. It is by Zoltán Baj Institute. This equipment is also under purchasing, but the throughput time is quite long for such a complex system. It gives the opportunity for a real emotion simulations. So this is how the science park laboratories next to the proving ground are and will be further developed in the future. And this is my last slide, that of course the human resources are key for all this kind of activities. So that's why also in this science park buildings, we also give a job for dual and trainee students. We have around 1,000 engineering candidates from various universities. And of course, these students after graduation can stay for working as a normal working contract and get a job either from the proving ground operation company or by industrial companies who create their local site or by R&D. It's very important to ensure the continuous flow of resources. So very briefly, this is the science park concept. So how we approach and how we try to create and build up the local environment for this kind of added value activities. Thank you very much, and if there are questions, I am glad to.
Thank you so much, Mr. Háry. Now, anyone that that have questions can please put the button, raise your hand to see if there are questions. There are some questions in the chat room. I don't know if Mr. Háry, you can see them. If anyone from the attendees would like to speak and ask the question directly to Mr. Háry or to any other Hungarian speaker, can now do it. Otherwise,
See the questions in the chat room.
Mm-hmm.
So one question was, what's the overall infrastructure budget investment of the science park? So it's a continuous activity, and there are also privately invested buildings. There are also university investments, for example, into softwares and laboratories. So it's a mix of many small investments, but altogether the overall budget currently is around some €5 million, and it will go up to around 20 million euro in the coming 2 years.
Okay. Another question I see is if a Greek startup can collaborate in the smart city domain, from Mr. Christos Pateropoulos.
Yes, smart city and the city testing environment is a special part of the ZalaZONE, and also there are R&D activities related to that. So I think that maybe Viktor has a better position to answer this, but I think yes, the university teams are open for any relevant cooperation, and if the startup would like to rent this smart city for testing, then this is a kind of industrial utilization presented by Robert.
Yes, exactly. So if it depends on what kind of collaboration you imagine with this startup. If this is on a research level, then this belongs to the ZalaZONE research, to my part actually. But if you want to only rent the smart city part, or service from the ZalaZONE team on a commercial basis, then Robert is the good one to collaborate with.
Okay. I see another question that except big freight trucks, do you also test last mile delivery utility autonomous vehicles? If you test, can you see it on the chat room?
Yes, we can see.
On the chat room, there is another question that writes, except from big freight trucks, do you also test last mile delivery utility autonomous vehicles?
Yeah, actually, from my side, I may answer that. So currently, from the research part, we do not test this use case, but the proving ground has the ability for that. So if you would like to test such scenarios, then we are absolutely open for that.
Okay. So I have another, just a minute, Mrs. Zarkadoula from the CRES that has, I will give her.
Okay, do you hear me?
Yes, Mrs. Zarkadoula.
Okay, following a previous question about how you can see an opportunity of collaboration between ZalaZONE project and the Greek partner, I have to say that at this moment there is a governmental initiative about the post-lignite period. So mainly in the Western Greece and the Western Macedonia and Peloponnese are prepared for the transition to a clean energy status. So in this area, there is a number of projects for the post-lignite period. So it's foreseen also a business innovation park concerns these issues like the one of ZalaZONE project. So my question is there any opportunity, and in which way you can see a kind of collaboration in order to develop such a kind of business innovation park in these areas? Do you hear me?
Yes.
Doctor.
I know. Okay.
Yes, we hear you. Dr. Háry, did you hear? Did you understand the question? Because
Each other, so fast should give an answer. But so basically, the point is that if as Viktor mentioned, if the nature of the need is R&D related, then the way of establishing a cooperation is the R&D group. It's headed by coordinated by Viktor Tihanyi. If it's more market-based, so just having an access to a proving ground renting modules, then it's Siddi. But of course, we are open for any collaboration. So if, for example, this initiative what you mentioned is about cooperation of Greek partners and the Hungarian partners, there can be also a joint project. So I think it's open. Fine. Your question.
Okay. Thank you.
I would like to add something, because I think that the Hungarian partners, Mr. Háry and all they are not aware of this initiative that you are mentioning, Ms. Zarkadoula, which is very big now here in Greece. So our proposal as HEPA is first to give to ZalaZONE more clue about it. We as HEPA will inform you about what Ms. Zarkadoula told you, because it's a very big issue here in Greece that you are not aware now, I think. We will give you more details, and then we will make a connection together to speak more with Mrs. Zarkadoula, because it's a very, now in Greece, it's a big time for energy and green energy, and we have to give you more details about it, I think. So we will continue this communication in a different path. If you agree.
Thank you. Yes, of course.
Okay. Thank you so much.
We are at your disposal for any further communication or collaboration.
Okay, thank you. We have another question from Mr. Dimitris Margaritis. Now I will let him speak. Hello.
Good morning. Can you hear me?
Yes, we can hear you.
Good morning to the presenters. Thank you very much for this incredible project. I've been involved in testing of vehicles in the Netherlands, also in Spain with IDIADA. It's really to create such facilities, which is missing in the eastern part of Europe. There will be, of course, tough competition with other countries, like in England with Myra, but I think you can find your way, and also you can get support from the industry for several reasons that we cannot now explain. My question is how can we involve the facilities within European projects? CERF is initiating several activities. The largest automation project, the show in Europe with 30 million euros budget, for example, how can we make partner in a future initiative the facilities? Is there a legal status? Are we going to involve AVL? So please, if you can provide us some data or details, it will be very interesting to discuss future projects.
Yes, so Viktor, Tihanyi speaking, maybe I will answer that question. So if you are focusing on European funded research activities, is this the case? So maybe Horizon 2020 in the past or Horizon Europe projects?
Yes, you're right. And actually we speak for, I talk more for the future project, for the zero project regarding electromobility or autonomous driving. Green Deal is actually nothing that we can maybe do at this moment. It's a bit too late. But for the framework 21-27.
Okay, so the typical way for that, formerly legally the proving ground did not join these activities directly, but with a letter of support. And the representative in the project was rather the Technical University of Budapest. So this is the easiest way because we can get the full support of the proving ground, and we can also support from ZalaZONE the activities, but from a legal perspective, as a real consortium member, the proving ground was not able to join just in this way.
Okay, thank you very much. I will then discuss with the people from the embassy regarding the details, or the person that we can speak with from the university. Or maybe you can also give it to me later on.
Yes,
yes, actually, just to answer you, so typically from the university, I was the contact person, so it's, I think, very easy to establish this connection.
Yes, but we will, of course, we will be at your disposal and we'll make this communication work. Okay, thank you very much, Mr. Margaritis. I have seen no other question. On behalf of the Hungarian Expert Promotion Agency and from the Embassy of Hungary in Athens, we would like to thank you all. I would like to thank you all Hungarian speakers, Mr. Tihanyi, Mr. Siddi, Mr. Háry. Thank you very much. We will be at your disposal, the HEPA Office of Greece. And to the Greek attendees, I would like to thank you all. And we are at your disposal for further communication and more specific project for cooperation. So thank you very much for today, and we'll see you soon. Okay.
Thank you very much also for your help to organize this webinar.
Thank you.
Thank you.
Bye. Bye.